this before and then I forgot. So I'll go back and show you. But for example, let's see, where's one that would be? Well, shoot. There's a problem we did. This is on page 48. Right, and we did this graphically. Now, this little sucker is an expensive graph, or this TI calculator. So let me show you, I just want to show you real quick. If you don't have this, you just watch. You can solve, let me really hook you in and then remind you that you got to show me work. You can solve any equation that exists, wherever it did exist, or wherever it will exist, you can solve it. You can solve for y, you can solve it using the calculator. Even if it's got squares and stuff in it. So let me show you the basic method. So I put in here 2x minus 4, that's the first guy. And then I'll put the second guy in here, negative 4x plus 2. When I hit graph, it's going to graph both of those lines. And we know the answer is where they meet. Now what else can I call that? It's where they intersect. I love it. Kick ass. I think I showed you this a long time ago. Just reminding you guys. So if they graph, let's see what kind of freaky window I'm in. Oh, I'm in a normal window. Think of. There it is. Sweet. You can see where the intersection happens. So if I hit second, calc, I can see my intersect. It's going to ask me 3 questions. It's going to ask me the first curve. Yes, and in math we call this a straight curve. We do. We're weird. If you hit enter, notice how it bounces up to the next curve. Enter, and then it asks for a guess. You try to get it on top of the answer. Enter. And there's the answer. 1, negative 2, and that's what we got over here. 1, negative 2. Yay! So even if I had an equation like something exceptionally weird, what if I had an equation like y equals x squared minus x plus 1, and y equals, what you got, Jeff? Negative 2x plus 3. I can still use that same method to solve these. Put in there x squared minus x, what did I say, plus 1. And you put in there, what else did I say? Negative 2x plus 3. When you graph them, you get the parabola that some of us should have realized was going to happen. And then you get the line. And how many answers do you see? 2. 2. Beautiful. I like it. So then you can find each answer just by doing the intersect dude. Just go enter. Now it's on the other line, enter, and now you put it close to the answer, enter, bam, and it tells you there's the answers. That's where they meet. Kick ass. So even like, let me make this one final statement. Let's go way back in time. Back here when we first did solving equations, let's see if I did any in the book here. No. All right, that's all right. Like if I had to solve this equation, this one right there, I could go to y equals, I could put one side in the calculator, 4 times x plus 2, minus 2 times 2x plus 3. That's one side. And then I can put the other side, 10. And the answer is where they both meet, because it's saying one thing equals the other one. So if I graph this, all right, now something went freaky. What have I done? Is it just because I don't have times? Maybe it's just because I don't have times. Oh, it's because, oh, the answer to this is freaking no solution, that's why. Can you guys see? I just realized. So the answer should be where they meet. And of course, they don't meet. You guys with me? That's not very eventful. So yeah, you get another one. Let's see, this is a special, oh, this is a special situation. Oh, here we go. Here's the other one. This guy. This is page 3. So if I put in here, negative 5/6x, I can just replace that with an x. Negative 5/6x plus 2/3, that's one side. And then 2 plus 1/2 x, that's the other side. So just put both sides of the equation in. So I'm going to have, when does this line equal that line? That's really what that equation means now. I can see that going back. Based on what we've done now, I can go back and reinterpret this. If I graph these, a little glare. There we go. I can see there's the answer, and then if I go second calc, intersect one equation, the other equation, and then my guess, and they tell me the answer is -1. In this case, I don't care about y. Why? What's the only, remember, replace the stupid r with x, okay? The only letter that shows up in the equation is x. I don't care about the y. So the answer for this would be -1. You can do any equation you've ever had to do and ever will have to do. You can check it graphically by putting one side in y1 and the other side in y2 and seeing where they meet. To check your work all day. Better freaking show me some work though. It's always nice to be able to check and make sure you get the right answer. Alright. For right now, I want to go back in time a bit. Let's see. And make sure we're all cool with certain things. I think we should all be really cool with just this basic idea of elimination. But you definitely have to be able to do this to be able to do the matrix stuff. Matrices are built off of the idea of elimination, right? You use a 1 to kill another variable. You make a 0. So that idea of making a 0 is the same thing as eliminating a variable directly. Something weird is going to happen on this one a little bit. Well, what letter would you like to kill?
-6.
The x? Okay, so what are you going to multiply the first one by?
3.
Why not -3?
2x.
Because they're already what?
Different side.
Different signs. So just multiply by 3. I'll get 6x minus 15y equals 30. This is page 53, by the way. I love this. It's going to happen. And of course, what do you get when you add these together?
12x.
Let's try it again. What are we adding together?
Oh no, oh my God,
Just a little bit. A little bit. Brought everybody with you, it's all right.
0.
Yeah, I get 0, right? Well, that cancels. 0 equals 0. What does that mean? You don't circle that thing. Now be really careful.
it's the same line.
It's the same line, which means what's the solutions?
Infinite.
That's, well, okay, there's an infinite number of solutions, but what are they?
The same thing.
All together.
Remember, what is the answer to a system of equations? It is the point or points where the lines
Oh, infinite.
meet.
Infinite.
It's a point or points. So where do these two lines meet? You're right, they're the same line. So what points do they meet at?
At 0, 0.
As long as they
All
are.
of them
All the points that are
on the line.
on the line. Sweet. They don't meet at every point. They meet at all the points that are on the line. That's why there's an infinite number of answers. So the answer to a system of equations is always where the things meet graphically, be they lines or planes like we talked the other day. But they could meet at more than one point. Lines could be right on top of each other. So there's an infinite number of answers, but what are they? all the points on the line.
So that's your answer?
Yes. I like it. So the answer is all points on 2x minus 5y equals 10. Because they really are the same. They're both 2x minus 5y equals 10. Just one of them somebody multiplied by negative 3. But they are both this. You guys see that? If they cancel, they must both, one must be a multiple of the other one. That's the only way they can completely cancel. Now, it's nice if it's 0 equals 1. What does that mean? It's just straight up no solution. You don't have to say anything special. Just no solution. Where do they meet? Nowhere. No solution.
If you would have killed Y, the same thing would happen.
Yeah, how would you have killed y? You would have tripled it to see the same thing. Tripling kills either one, that's why they both die. I like it. All right, now let's look at a word problem. Let's do one let's do a small one. This is page 55, number 3. Go ahead and try to set that up. Oh my. 20 points to Gryffindor. Yes.
After this, do we do number 2?
Number 2?
Yeah.
Sure. Yeah. Okay. So after this one, we'll do 2. You read it in a beautiful British accent. You do it. It's going to impress me.
Always for you, Jack.
What are my unknowns? What needs variable names? What about dimes and nickels?
You don't know.
The number of dimes, and the number of nickels. So what do you want to call the number of dimes? No way. What about the number of nickels? You can call it whatever you want to, but my God, make it make sense. Don't make call them X and Y, A and B. So there's almost always going to be one equation where you just sum up the letters and it equals something. Obviously, if D and N are the number of coins, when I add them, I'm supposed to get 36. So here's something you can always do with these word problems is G is a number of dimes, N is a number of nickels. So whatever goes on this side better be a number of coins. So 36. I wouldn't put 290 here. I haven't brought money in yet. No C-shirt. So how does money come into play? Every dime gives you how much money?
10.
That's amazing. 10 cents. Right? And every nickel gives you 5 cents. So it's really up to you how you write it. Now, if one side is cents, the other side better frickin' be cents. So if I do write this, 10 times the number of dimes, plus 5 times the number of nickels, what must I put on this side? So you guys see this. 290. Cents plus cents equals cents.
Could you do like 0.10?
You totally could. You could write 0.10D plus 0.05N equals 2.90. But then the first thing I'd want to do is multiply everything by 100. So my suggestion is a lot of the time when they give you like $11.50 or something, make it into cents. That would eliminate the decimals right away. So instead of putting 0.10 for dimes, put 10. Just make sure that on the other side, it's got to be in cents also. So whatever one side represents, the other side has to represent the same idea. Cents plus cents equals cents. Dollars plus dollars equals dollars. Amount plus amount equals amount.
Equal exchange.
You guys with me? All right. And now what do you do?
Calculate.
Or bring them to the other side.
Yeah, all right, I love it. You can use elimination. You can use substitution, right? The first one I can solve for n and plug that into the other one. I could do what? If I want to do elimination, what can I do? Multiply the first one by -5, I like it, or -10, whichever letter you want to kill. All right, go ahead and pick away, solve it. Doesn't say a specific way to do it, just do it. Alright, so let's see. Personally, I kinda like elimination method, so I would take this guy, maybe multiply by -5. -5 times 36, I get 1/8. I'm gonna rewrite the second equation down here, and now I can add them together and kill the nickels. -5 means n is 5d equals 110 divided by 5. How many dimes you got? 22. 22 dimes, how many nickels must you have? Dimes plus nickels equals 36. 22 dimes, so I must have 14. Now you guys might have done a substitution method instead, or you might have killed the dimes instead of killing the nickels. Hopefully everybody got down to there. I like it. All right, let's try a triple one. Crazy. See if I have any left. Oh wait, sorry, Kendall, you asked for number 2.
Yeah.
Something freaky happened? Oh yeah, all right. They love this kind of problem about the number of legs and stuff. Just to make sure everybody's, this might give something away, but how many legs does a duck have? 2. I want to see that 4-legged duck right there. Let me I'm gone. And of course, a cow's got 4. All right. So try to figure out how to set this sucker up. Do you see 2 relationships? Not 2 things. I see cows and ducks. Great. 2 relationships. That's where your equations come from.
Huh?
2 duck legs.
I wasn't so sure, but this is how I broke it down for myself.
Duck's got 2 feet, that's right. So, but do you see, what are the 2 ideas that are going to lead to 2 separate equations? The amount of legs, I'm going to have a leg equation, which is the weirdest phrase you'll ever hear. Got to get the leg equation set up. And then what's the other idea? Number of animals, right? And in fact, I don't know how many of each animal does he have, so that 24 is going to be that simple equation where you just add the variables up, and it equals a total. You almost always have like a plus b equals number equation. Well, obviously here I'm going to use what letters? Q for quack and M for moon. So what's Q plus M? 24. This is the number of ducks and the number of cows, right? How do I set up the legs equation? Every duck gives me how many legs?
2.
2. Every cow gives me
4.
4 legs. And then how many total legs do I have? 62. I really, do you guys see what I mean about, all right, there's 2 ideas. Each idea is going to set up an equation. Those ideas also make sure that I got the right things in the equation. Amount, legs, legs, legs. And now solve it however you want to. Elimination or substitution. I'll do this one the substitution way just to review that. Do it whatever way you want to. see, I solve for M just cause.
Yeah.
Doesn't matter which one I solve for here. And now I can plug the 24 minus Q into M, so I get 2Q plus 4 times M, but M is this. So I just rewrote the same thing, I just replaced M with what it is. And then I can distribute. Get my like terms together, subtract 96. 2Q minus 4Q is negative 2Q. And over here I get negative 34. I think. And then divide by negative 2, I get 17 ducks. That's how many ducks I get, 17. And how many cows? Yeah. 24 minus 17, I got 7 moo cows. My mom used to say, moo cows. I'm like, what the hell else is cows are? That's what it is. Alright, cool. Let's do 1 with 3 variables and then we'll call it a day. That's that section 9-2, that last section you gotta worry about. I don't know why they put it after 9-3. Page 68. All right. This one is a little involved. First thing is just what are my variables going to represent? This is, did I tell you page 68? What are my variables going to represent in this?
Percentage.
No. Because I know those. I know they're 10%, 6%, 15%. They're not variables. What are my variables going to represent? What about them?
First fund, second fund, third fund.
What about them?
How much they grew.
No. What is it that I don't know? Well, what's the question say? Ah, okay, so the amount invested in each. You guys with me? So this is one of those problems I warned you about. This is the silly problem. This dude's like, I don't remember how much, was it 20,000? I don't remember how, I'm like, dude, what a problem to have. Oh, look at this book, it's $20,000, how much? So the amount invested at, I got a 10%, I got a first fund, all right, a second fund, and a third fund. So what do you want to call each one?
A, B, and C.
Yeah, it really doesn't matter, but, all right, we'll do A, B, C, why not? So that's the amount of money. Oh, this is imaginary. Well, this is something I live all the time. I got imaginary $80,000 all over this. What's the very first equation I can write? It's always the easiest one. It's just straight up. Each of these represents an amount invested. A plus B plus C equals 80,000. I love it. The little wishful money in his head. So one equation is just A plus B plus C. The total amount you dreamed about was 80,000. Now there's got to be 2 more equations. The first fund grew by 10%. So how much earnings were from the first fund? How much money did it put into the first fund? A. And how much earnings did I come off of that? 10% of A. So it's just like 2 legs per duck. So I put 2Q, because the total legs per duck times the total number of ducks. The amount of money per fund times the I mean, the amount of interest per fund times the amount of money in the fund. 10% of A.
10A plus.
Yeah, okay.
6B plus.
You gotta be a little careful. I like it. So 10, if you say this is totally cool, I love it. 10A plus
6B.
6B plus
15C.
15C. Gotta be really careful if you're doing something. So if 10A is the amount of money I made off of that account, right? The amount extra I earned, plus that is the amount extra I earned, plus that is the amount extra I earned. They better all equal to what? Total earnings were 8850, but be careful. What did you kind of do as you were doing this? What is 10%? Is it 10? No, it's 0.10. So you moved all the decimals over twice, so you better move the decimals over twice on that one too. Oh shit. So really, here's how it looks to begin with. 0.10A plus 0.06B
Just like the
plus
first one.
0.15C. Yeah, except the first one's a little bit in your face sense. This one is percentages in dollars. You still got to do the same idea. So I could immediately just move these over twice, as long as I move this one over and get 2 more zeros on that sucker, right? There's always a trade-off for killing fractions and decimals. All your numbers get bigger. Stay with me. Now what's the third equation? That one's one where they just tell you straight up, but you got to be a little careful. The earnings from the first fund. That's not A. What are the earnings from the first fund? Good, 0.10A. Earnings from the first fund were $750 more than the earnings from the third fund. Earnings from the first fund were $750 more than the earnings from the third fund. Oh shit. So you gotta be really careful. In this problem, A is the amount I put in. Earnings, hopefully you understand this, you put money in the bank, and your earnings are the percentage of the money you put in the bank, right? And that's why I look at it, it's like, plus 5 cents. Ha-ha! Huzzah! All right. So this was definitely freaky. But it's not horrific. Because now, like I said, the second one you can clean up by moving all the decimals over twice, including here. And the third one you can do the same thing. Let's see if you guys see what's here. Let's do that and take a look at it fresh. So the first one stays the same. The second one becomes what you're trying to tell me in the first place. 885,000. Because I moved all the decimals over once, twice. I got to move this decimal over once, twice. And the third one becomes 10A equals 15C plus 750,000. Oh shit. You can kill decimals as long as you move the decimal places for everybody. That's the only way to make it legal. And do you see how the third one is already missing what letter? B. So between 1 and 2, I'm going to kill B one more time. I only have to kill B once because it's already dead in one of these. So somebody already did the first step for me. Do you guys see that? Anytime a letter is missing, at least one letter is missing, there's a quicker way to get there. So how can I kill B between 1 and 2?
Divide by -6.
Here,
Times by -6.
Yeah, so if I take the first one, oh my god, there's so much shit here. Take the first one and multiply by -6. Yeah, then plus. Let's see, that's going to be -480,000. Woo! And then if I add this and this together, the B's are going to die. So here's my original problem. And now I'm taking the first one, multiply by -6, so it can kill that B right there. Kill that sucker. So let me see, I'm going to run into this next problem. If I add these together, I get 4A. The B's die. 15 minus 6, 9. 885 minus 480 is 405,000. That's equation 4. Then I got equation 3, 10a. Let me see if you guys are cool with this. I'm going to subtract the 15c over just so it's set up the same. Let me stop there for a second. So all we did was we said, okay, we got to kill the letter twice. B's already dead here. So that's half my work done. I just got to kill B one more time. So we multiplied this by -6 so that these B's would kill each other. And they did. Here, all I did was subtract the 15c over so they lined up. And now between the two of these, however you want to kill something. Can you divide by anything? No. Well, you can divide this one by 5, but you might not notice that. I don't know. Anytime I can divide by something, I do it. If I divide this by 5, this will be 2. This will be -3. See, that'll be easy to kill then. Do you guys see that? Yeah. Or I could just multiply this by, get these to die or something. I'd much rather divide this sucker by 5. You guys have a good time. So if I divide this one by 5, that becomes 2a minus 3c equals, what is that, 15000? 75 divided by 5. And now, I'm tired. Now between these two, you can kill C, right? You guys see that? Okay, so there's a lot going on, and I totally understand. But anytime you see an equation where something goes into all three, I want my numbers smaller because then it's easier to match them up and kill something, right? We see that happening right now. The 15 became a 3. Now I triple that sucker, it's going to kill the 9 in equation 4, right? The 9c. So I triple that sucker there times 3. And bring down this one. Now the C's were going to die. Alright. So do that, you get 10a equals, are these both positive? Yes. 8, 5, 5, 0, 0, 0. So A, divide by 10, I lose a 0. 8, 5, 5, 0, 0. Which doesn't make sense. So somewhere I have too many zeros. I'm sucker now. Oh, that's 405,000. Is that what's that supposed to be? 45,000. That's what I did wrong. Right here, I just did this wrong. My bad. Trying to do too much at once. 45,000 plus 405,000 is 450,000. That's a better job. Then when you divide by 10, you get 45,000. Okay. How did I know? All right. So how did I know I made a mistake? How much total money do I have for this problem? 80,000. And here I was saying that one account had 85,000 in it. So I was like, Jeff, you obviously did something wrong. So I gave this extra 0, I think, in my head when I was doing this. So it should be 45 plus 405. So now that you know A, you can go back and figure out what C is. And once you know both of them, you can plug it back in, the original. All right. I'm done. Everybody got a practice test, right?
Yes, sir.
Okay. I think it's plenty for today. So don't forget, don't worry